Good morning, students. Today we are going to discuss e- electrochemistry part 1. So first of all, what is electrochemistry? So the branch of science that deals with the study of chemical effects of electricity and electric effect of chemical reaction is called as electrochemistry. Whenever a potential is applied to any substance, it may or may not carry electricity. If substance conducts electricity, then we call it as a conductor. While if a substance does not conduct electricity, we simply call it as a insulator. In a case of a solid, the conduction of electricity is due to the free electrons, while in a solution it is due to the ions. Solid conduct electricity without undergoing any chemical change, while liquid undergo dissociation to produce ions, and then these ions migrate under the influence of applied potential, leading to conduct electricity. The solution which carry current, we simply call it as a electrolyte solution, while those do not carry current, we simply known as it as a non-electrolyte solution. Now we are going to understand some basic concept of electricity or electrochemistry. So first law is called as Ohm's law. What is Ohm's law? Current flowing through the conductor is directly proportional to the applied potential. So E is directly proportional to I. So we can write it E is equal to IR, where R is basically resistance. Now what is a resistance? What is the definition of resistance? So from this formula we can create a definition of resistance. So resistance is the ratio of applied EMF to that of current flowing through the conductor. The ratio of applied EMF to the current flowing through the substance is called as resistance. So EMF, unit of EMF is volt, and unit of current is ampere. The unit of resistance, it is volt divided by ampere, so it is simply known as ohm, and it is denoted by this symbol. Now what is conductance? So reciprocal of your resistance is simply known as conductance. Conductance is the measure of current carrying capacity of the substance. Generally it is denoted by capital C. So C is equal to 1 by R, reciprocal of your resistance. So unit of conductance is, unit of R is ohm. So 1 by ohm is simply ohm inverse. It is also known as mho. Symbol is like this. It is also the unit of conductance is Siemens. All of these units are same. Now we are going to discuss specific resistance or resistivity. Resistance is directly proportional to length of conductor, and resistance is also inversely proportional to area of cross section of conductor. So we can directly write R is directly proportional to length of conductor, inversely proportional to area of cross section. So R is equal to, this symbol is known as rho. So R is equal to rho multiplied by L by A. Where, so what is specific resistance? It is defined as resistance offered by a conductor of unit length and unit area of cross section. The unit of specific conductance is ohm meter or ohm centimeter. Now what is specific conductance? The unit of specific resistance is ohm meter or ohm centimeter. Now what is specific conductance or conductivity? So simply the reciprocal of your specific resistance, it is called as specific conductance or conductivity. It is generally denoted by K. So K is equal to 1 by rho. The unit of rho is ohm meter. So K is equal to 1 by ohm meter. So it is ohm inverse meter inverse or mho meter inverse or simply Siemens meter inverse. All these units are equivalent. Now these are two quantity is very much important for us, that is equivalent conductance and molar conductance. Now what is equivalence conductance? The conductance of a solution containing 1 gram equivalent of an electrolyte. This term, that is 1 gram equivalent, it is very much important. It is related with equivalent weight. So the conductance of a solution containing 1 gram equivalent of an electrolyte is called as its equivalent conductance. It is denoted by lambda. It is given by lambda is equal to K by C, where C, small c, is a concentration in equivalent per cubic meter. The unit of equivalent conductance is simply Siemens equivalence inverse meter square. Now this is important. 1 Siemens meter square equivalence inverse is equal to 10 raised to the power 4 ohm inverse centimeter square equivalence inverse. Now what is a molar conductance? The conductance of a solution containing 1 mole of electrolyte is called molar conductance. It is denoted by mu. Its unit is Siemens mole inverse meter square. So mu is equal to K multiplied by V. So V is equal to 1000 divided by molarity for molar conductance. So we can write lambda is equal to K multiplied by V. So K multiplied by 1000 divided by normality. It is important. The term here molarity and term here normality, because it makes a big difference. Now we are going to see effect of dilution on specific conductance, that is K, and equivalence conductance, that is lambda. Now always remember that conductance of a solution depends on number of iron present in it. More is the number of ions, higher is the conductance. Now what is the definition of specific conductance? Specific conductance is the conductance of a solution having unit volume. It is important. Having unit volume, that is 1 meter cube or 1 centimeter cube. When solution is diluted, the number of ions in a unit volume goes on decreasing, and so specific conductance goes on decreasing on dilution. Now just see that, if just see this diagram, this is the unit volume which is equal to 1 meter cube, in which 6 ions of electrolyte is present initially. Now what happens when we are going to dilute this solution? So after dilution there is a migration of ions, means ions get move away from each other. Due to that, in a second diagram, in 1 meter cube volume, we see that there is only 4 ions are present. So before dilution there is total 6 ions is present. After dilution there is 4 ions are present. And what the specific conductance is, simply say that it is the conductance of solution having unit volume. And we know that conductance is directly proportional to number of ions. So before dilution conductance is more, that is specific conductance is more. After dilution number of ions in 1 meter cube volume decreases, so specific conductance is also decreases. Now we are going to see what happened with equivalent conductance. Equivalence conductance is the conductance of a solution containing 1 gram equivalent of a solute. So in a case of equivalent conductance, it is not limited by unit volume. Your equivalent conductance is not limited by unit volume. It is the conductance of 1 gram of equivalent of solute. So it is given by lambda is equal to K multiplied by V. So when we dilute anything, volume increases. Since volume increases, it simply means that lambda is also increases, because the in equivalent conductance definition it is not limited, this definition is not limited by the word unit volume. So as the volume increases in this formula, lambda value is obviously increases. So due to the dilution, specific conductance decreases while V increases. The increase in volume is higher than decrease in specific conductance, and so the equivalence conductance lambda increases on dilution. So just see here, your equivalent conductance is product of two quantity. One is specific conductance and second is volume. What happens when we dilute the electrolyte solution? So obviously specific conductance value decreases and value of volume increases. So in this case one factor is decreasing, other is increasing, but the overall effect which is experimentally seen that value of lambda increases, means effect of volume have more effect. It is the increases volume is more as compared to decrease in specific conductance. So on a dilution, in short word we can say that on dilution specific conductance decreases while your equivalent conductance increases, because equivalent conductance definition is not limited by the word unit volume. Now we have to see nature. The nature in increase in equivalent conductance depends upon the type of electrolyte, because we have two types of electrolyte. One is strong electrolyte, generally KCl, NaCl. Another one is weak electrolyte. So this is the graph which show overall effect. So on y-axis lambda is plot, that is equivalent conductance value of strong electrolyte and weak electrolyte is plotted on y-axis. On x-axis under root of C, that is concentration under root, is plotted. So from this graph we see that from strong electrolyte there is a limiting value. It increases slightly. Strong electrolyte value for equivalent conductance, it is increases slightly. So the equivalent conductance of strong electrolyte slightly increases due to dilution. It has limiting value of lambda, which can be obtained by extrapolating this line on your y-axis. Now just see what happened with your weak electrolyte. As we are going to dilute the solution, this value increases sharply, and there is no end, there is no limiting value for your lambda in case of your weak electrolyte. So this show that in a case of strong electrolyte, this show that strong electrolytes are completely ionized at dilution. Equivalence conductance of weak electrolyte increases sharply. It increases sharply on dilution. There is no limiting value for lambda in a weak electrolyte. So in our next class we are going to see experimental determination of specific conductance and equivalence conductance. Thank you very much.